Hello, it's What the Doodle here, and for this session I'm going to try and explore two types of programming style. One which is declarative and the other which is called procedural or imperative sometimes. They are interchangeable. And they're just two different styles. Ultimately they achieve the same thing in terms of output, but it's a different way of tackling the same problem. So for this example, I'm going to just use JavaScript. That's not an endorsement of JavaScript, but it's simply because it's kind of like the lowest common denominator on the web. So in order to do that, we need a JavaScript runtime, and I'm going to use Dino mostly because it's written in Rust, but also it has the same kind of feel in terms of tooling because it's a single binary that essentially has everything built in and baked in, and it's really nice in terms of dependencies and productivity. So let's grab that first. We'll use Pacman. I don't have it installed, so let's grab that first. Let Pacman do its thing. Yes, we'd like to install it. Go ahead and let that install. Fantastic. Right, let's just check that we actually do have Dino. Yes, it looks like we have Dino. What is the version, just out of interest? Yep, okay. So that's fine. Let's now go into our desktop. Let's clear everything. What we'll do is we'll create a new folder called example and go into that folder and have a look around. There's nothing there as we'd expect. We're going to create a new file called demo for the example, and what we shall do is now jump into a new panel and let's boot up Visual Studio Code when it opens up, and let's open the folder. We want the example folder, which is perfectly fine, so that should be fine. Okay, so now, so we've got our little terminal here, which is fine, and we've got the demo. So let's just make sure everything is actually working. I mean, there's no reason why it shouldn't. We should say the usual hello world as a test, and I can't type, make a lot of mistakes. So do you know run? Actually, we should be in the example folder, and let's do Dino run demo. Okay, I've typed it wrong. Should be Dino run demo. Yes, okay, perfect. So yes, Dino's working, installed correctly, and it's all working and running and compiling, not compiling, interpreting, I should say. Okay, so for this example, let's create a silly little data structure or something. So let's try and keep it real, not real world, but sort of something not completely alien. So let's just say an array, if you like, of objects of people, and I don't know, let's just say age 21, name, let's do something like Fred, and what we'll do is we'll just copy that and paste that a few times. So let's, I don't know, just change it to Bob, James and Eddie and Pete, and let's just do another one. Okay, fantastic. So let's just mess around with these ages. Let's keep that as fine. Let's just say that's 33, I don't know, 48. Let's do someone who's 55. There's someone who's youngish, and let's do 36. Fine. So we've now created. Let's just make sure we haven't all the code is fine. So let's just do Dino run demo. Yes, fine. So okay, we've created an array of objects, and we've obviously got ages and names in there for that. And just as a really crude example, we will first do the procedural way. So for the procedural style, we will build a function, let's say, that gets the maximum age, and then at the same time it excludes a particular name. I don't know why, but it's just as an example. So let's create that function. So max age exclude name, and it will take some data structure and the name to exclude. Now we have to unfortunately use these sort of temporary variables, so let's call this result. So it's just an object, and then what we'll do is essentially we will loop around. So we will say let's I, because these horrible sort of variables that we have to use when we're doing these kind of very procedural way of doing these things, and it becomes almost like rote memory after you've done it so many times. But it's you know, it's so easy to make so many mistakes because it's just so laborious and so mechanical, and it's not actually, it's kind of deviates away from the actual problem that we're trying to solve. So we're looping through this data structure, if you like, one element at a time, and then what we're doing is we're saying, okay, so if we look at that particular indice set by I, and if the age is greater than the result.age, I don't know if this will break because obviously that object is empty, it's not initialized, but this is JavaScript and everything's all kind of, this is the way things are in JavaScript. So people index dot name, we could probably combine this into one, but I'm just doing it as a nested if. So if the name is not equal to the name that we're passing, then of course what we'd like to do is we'd like to set the result to that particular indice. Okay, and then finally we just want to return that result. Okay, we can then test that console.log max age excluded name, pass the people down, and we want to exclude let's say Dave. So let's see what happens if we now run that Dino run demo. We get an empty result. Okay, so we've got an empty result, but this is exactly the reason why dynamic languages are frustrating, because this code is kind of stupid. It shouldn't really compile, but because it's dynamically typed and interpreted at runtime, it allows you to write essentially completely balked code, even in this most ridiculously simple code. Now, of course, did you notice it? Well, I didn't, and probably you'll argue there's linters and stuff like that that could potentially help. But I mean, or you know, static analyzers and whatnot. So but the problem there is by the time you've added static analyzers and linters and then all of these other things, and then of course the TDD crowd would be screaming, it's like, oh well, you should be adding all that. Well, once you've added all of that stuff, at that point you might as well just use the compiler. Anyway, rant aside, so let's just fix that. So length, that was incorrect, and of course we had an uninitialized variable. So if we now do this, now if we run Dino over that demo, and as you can see, it now correctly gives us the maximum age. That is not Dave. So Dave is removed from there. But let's try actually changing Eddie, because let's say we want to get the maximum age that doesn't include Eddie. If we run that again, we get James, which is the next highest, next oldest person in terms of age. So clearly this is working, and but it's procedural. It's very step by step, very error prone, and throw into the mix a dynamic interpreter language, and it's just really not a nice experience. Okay, so how would we do this in a more declarative way? So let's comment this out for now, because we don't want this. We don't want to use the imperative style. So what we'll do is we will create a new function. We'll call it the same thing, so max excluded name. And essentially what we'll do is we'll take some data array or something and the predicate, which is the name itself. And what we'll do is for the array, we will sort it, and what we want to do is we want to sort it by, so each of the elements, if you like, we want to sort it by the age, because that's what we're doing. We're sorting by the age. And then what we're doing is we're doing a filter on it. And what we're doing for that filter is for each of those elements, if the name is not equal to the actual name that we're passing as a predicate. And then finally we are yoinking, if you like, grabbing that because obviously this is what we're doing is we're sorting a list by age, and then we're filtering it in the filter condition, and then at the end of it we'll get a list, but actually we want the object, so that's why we take whatever is at that top, if you like, taking the very first element. But of course it could be empty, so we just basically do the same. We just say age is 0. So this could come back as undefined if, for example, none of the criteria match, or if we have an empty data structure that's passed, for example. So we essentially just short circuit that, and we use this to kind of default it. It's exactly the same that we're doing here. Now, if we run this, let's see what happens. We get back James, which is exactly as we had before. But obviously, I just wanted to kind of show you just the complete difference in these two styles. And here is the procedural step-by-step mechanical way of building that function, if you like. And here is the declarative way. So obviously here we are mixing up, if you like, our intent. So what is the actual thing that we want, and sort of a very mechanical way of mutating variables and things like this. And it gets really muddled up in terms of the intent and what you're trying to do, because there is a combination of having to almost tell the computer step by step what to do. Whereas in the declarative, we don't care about how the actual steps are taken, but we care more about the intention. And as you can see, it's literally a one line. And I'm not saying it's not about code golfing here. It's about the actual intent is far more clear here than it is over here, because here it's lost in the, if you like, in all of the other steps that's going on, and a lot of it is actually just very crude and mechanical. We're literally giving baby steps to the actual computer. Do this, then do this, and hold this variable here. And it's, as I said, it gets cumbersome, it gets complicated, and you can imagine this is just obviously a very ridiculously simple example. But even in this very ridiculous contrived example, you can see just how, the difference. And obviously the more code that you have, even in this simple example, as I was writing this code out, there was a lot of errors and issues and a lot of things to think about. And this is just overhead in terms of cognitive load. Whereas in here, with the declarative approach, it's the intent is very clear, or much clearer, and so the stuff that in terms of things that you can get wrong is narrowed down a lot more. And that's really what we want to get towards. Is really that's what we're doing in terms of the actual programming. Generally, is that we have a certain expression or an intent or an idea, and that's what we're trying to achieve. But all of this is just tangential, if you like. So I would say this is tangential unnecessary complexity. Now, of course, some may argue, and there is some validity there, that this is very terse and it's very complicated, and if you're not used to seeing this could be more complicated, whereas this is anybody could read this and understand this. And to certain degree, yes, that argument, there is certain validity there, that this is simpler code. Somebody could argue this is simpler code, therefore readable by a wider audience, for example. And I would say that's partly because down to education. It's because we are so used to teaching this kind of this, I would say, almost old-fashioned way of approaching things. People have become accustomed to it, and they no longer see, because these patterns are so repetitive and done again and again. It's kind of been baked, and we have learnt to adjust and see those patterns and kind of almost not see the complexity, if that makes sense. Whereas if somebody was new to programming and they never learnt this style and they learnt this style, this would seem completely maddening. Like, what are you doing here if you look at it? So anyway, that's all I wanted to talk about in this session. Is it's a very small example, but I'm sure you can see kind of the benefit of a declarative style, and how you can get to the actual intent of what you want to express. So anyway, that's all for this session. So until next time, I'll see you in the next one.